Hello, everyone. My name is Jessica Rodriguez, and I want to say thank you to the employers for coming out and viewing our Capstone projects. We really appreciate it. For my Capstone project, I decided to make a smart baby monitor specifically to help prevent SIDS. So first, a little bit about me and why I chose this project. Before coming to C&M Ingenuity, I worked in the medical field as an EMT. And during my time doing that, I really witnessed some of the problems that can happen within the healthcare system, especially when hospitals are understaffed and medical professionals are overworked. Medical error, it's been estimated that medical error is actually the third leading cause of death in the United States. So now, with this being sort of my second career with technology, my passion is to create technology that makes it easier for medical professionals to do a really hard job, and it creates a safer environment for patients. So why did I pick SIDS in particular? The cause of SIDS is unknown, but I really believe that early detection has the potential to save infant lives. I've had friends, EMT and medic friends of mine that have gone on calls, and it's really unfortunate. There's not much that they can do for the infant because the infant hasn't been breathing for hours. So I really wanted to make something that could sense if an infant wasn't breathing very quickly, and that way the parents could get help immediately. So here's a quick video demonstration of the basic process that I went through to make this project and all the parts, how they work together. I started this project by creating the breathing band, and I did this using conductive thread and normal thread and crocheting them both together. Once this crocheted piece was long enough, I tested the change in resistance by creating a voltage divider and pulling on the fabric to see if the resistance would change. Next, I used the change in resistance to calculate the number of breaths. So each time the fabric is pulled, it counts it as one breath. Next, I worked on the self-rocking feature of the crib, and I did this by using a stepper motor mounted on some blocks of wood and positioned at just the right angle to where it rocks the crib every time it turns. Here I'm demonstrating the SpO2 monitor and the heart rate sensor working. I also use Zapier, so anytime the alarm rings, a text message is sent to the parents, and anytime the button is pushed, it simulates calling EMS. Here I'm demonstrating the vibration motor working. Next, I'm going to demonstrate how all the parts came together, and I'll begin by placing the fabric around the baby and fastening it with some safety pins. Next, I'll secure the SpO2 sensor onto the baby's wrist, and I did this by sewing the sensor onto some ACE bandages and cutting it to the baby's wrist size. So the sound that you just heard was the vibration motor turning on because the breathing band isn't sensing any movement, and the SpO2 isn't picking up any heart rate or adequate blood ox. This will be followed by the crib rocking and the alarm turning on shortly afterward. So that was I started this project by creating the breathing band. Sorry about that. So now I'm going to talk about the different challenges that I sort of overcame in making this project. The first one was, how do I actually sense the breathing of the baby? And I knew from my experience as an EMT in the medical field, we look at the rate of breathing by observing a patient's chest rise. And I wanted to make something that could transfer over to an infant and something that they could actually theoretically wear. So with the help of Brian, we realized that if I made the conducting thread and kind of fabricated it in such a way where it stretched, we could measure resistance. And from that resistance, we could calculate breathing. And here's the code that I used to do that. The next sort of challenge I faced was I wanted to add extra features to the crib to sort of awaken the child if the child kind of fell asleep and they weren't breathing. And the first thing I added was a vibration motor. And I was a little bit worried that it wasn't going to have enough power to actually vibrate the crib. So I created a relay to kind of siphon extra power from the particle into the vibration motor. And the next challenge that I faced was how do I actually get the crib rocking? So I tried a few different sort of mechanisms to get it to work. The first one was a slider crank sort of mechanism, and that unfortunately wasn't strong enough to move the crib. So eventually I laser cut the wheel that you see here and made out of acrylic, and it has a bolt kind of sticking out of it. And that combined with the stepper motor hooked up to 5 volts of power was enough to actually get the crib rocking. So the future goals for this project, I would really like to make everything wireless, kind of as an added safety feature, you know, because I don't want wires in the crib with the baby. That's sort of a safety hazard. And then I would also like to make add Bluetooth to make everything more connected. So again, thank you so much for everybody coming and seeing our presentations. This is my contact information, and I would like to open up the floor for any questions that any of y'all might have.